So this is the main landing dashboard for an Elastigroup account. With this, it's just going to show you the total number of spot instances that we're managing inside the account, the total potential cost, so what it would have cost for you to run these, all the different instance types and sizes for the amount of hours they're running, run those as on demand at the current market rates. Then we give you the actual spot costs that because we're leveraging those spot instances and their market rate there, you'll see the amount saved and the total percentage that we're saving against that on-demand resource market rate. It also shows that we do also have the capability of managing on-demand resources. Depending on the type of workload you have, you might have some databases, et cetera, that might need to be always running on demand and can't handle the service interruption of a spot instance. Those we can manage as well and automate. We have that capability of also running those in RI, so matching up the billing capabilities on the back end to really help take cost efficiencies into account. Looking down, just looking at overall resources in your account in AWS explicitly, we do have the ability to attach to GCP as well as Azure. We have the capabilities to across the board for multi-cloud. We saw some of those poll results before. So here we have the ability to look at reserved instances across your account, those that might be even vacant. So we'll take advantage of those before launching additional on-demand or additional spot instances, trying to keep down your overall cloud costs. With that, jumping into the Elastigroups, just want to talk real quick about some of the native integrations that we have in those public cloud providers. So as an example here in AWS, we can directly integrate into many of the services that they provide. So generic auto-scaling groups, load balancers, even Beanstalk, jumping into containerized workflows for Kubernetes or ECS, even Fargate. We can help to manage that and reduce some of the costs there by leveraging spot instances behind the scenes instead of using Fargate. Some of the other managed container orchestrators as well. So all of these do directly integrate with the Elastigroup, and we can immediately start taking advantage of the automation and workflow intelligence that we have built in. On top of this, we can layer Ocean for the containerized workloads. So those Elastigroups that you define with Kubernetes, either COPS directly into EC2, or if you're leveraging EKS as the management layer, we can provide Ocean as a layer on top of that to help really abstract a lot of the administrative overhead that you might be experiencing now. Jumping into one of our Ocean clusters here, we get a direct look at the costs that are associated with this particular cluster. We can see what kind of direct information feedback from the cluster itself, giving you some of that insight in terms of what version of Kubernetes we're running, the number of nodes, the pods that are active inside the cluster. Look at the CPU and memory allocation to the nodes and infrastructure itself. This does take into account that headroom that we have available, which is configurable by yourselves to really customize what kind of workloads you're running and make sure that you're satisfying those services. Have a deep look into, we break this down in a nice orderly fashion for the namespaces and each deployment they actually have. You'll see that this particular deployment, the total number of resource utilization inside the cluster, its costs associated with that, applying that back to the spot inst hours and things like that that are running, breaking it down even to the headroom. Full capabilities of reporting this. You can pull this information out with APIs, directly put it into some of your reporting tools so you can maintain trending analysis and everything going on. We also have the ability to, like I mentioned before, look at time series of data over the lifetime of the pods that are running. And we'll look at the definitions of what they have running versus the requests that are running versus what they're actually using over time. So we'll see here that this particular one has defined to use 0.1 vCPU per container and 200 megs of memory. But in reality, over time, it's actually using a little bit more vCPU and a little less RAM. So we could really we could tune in a finite manner to really take advantage of the efficiencies of bin packing these containers, getting them right-sized and appropriately put out there. Have a quick look at the infrastructure as we're controlling it. So as that serverless experience, we're looking at all of the pod recommendations or requests, pardon me, so all their vCPU, memory, if they need a GPU or not, do they need to run it on demand? We're taking all that information into account, and we're launching the infrastructure to match and to get great utilization resources versus what's actually being used by the containers themselves. So as you see here, we have a very varied mix of instance types and sizes. So M4s, R4s, 16XLs, 10XLs, mediums, etc., just to look at really maintaining that difference in how pods can be defined. We're looking at some that are on demand, leveraging reserved instances, and many of these are just running on spots. Containers being that native, stateless workload that can handle and being rescheduled into the infrastructure. We are constantly doing what we call simulated bin packing, looking at the overall architecture of the infrastructure, seeing where pods are deployed, and seeing if there's actually a simulated way where we could better bin pack those even yet further. So even those that are currently existed and scheduled, we're looking to see if we can rearrange those in even more efficient ways so that we can have better utilization of the infrastructure. Completely shrinking that overall footprint in the cloud, as well as having maximum utilization of the nodes that you are running. In our logged, fully logged infrastructure as to what's going on, so you can get full insight as to the activities that are happening. For example, when we scale down, we'll see that we're detaching these particular instances. You can pop up the details here to see the pre-scale event, overall cluster size, what it will look like after the fact, and see which individual nodes that we're actually taking down, and see how they're, what pods are finishing and what's being rescheduled, and which instances we're actually scaling back. And on the converse of that, we can look at those that are scaling up. See if I can find one in here. See, we have just one instance here being launched. Usually it'll have a particular set of requirements across the pods that are being requested to be scheduled. We'll look at that, take that into account, and then appropriately match that. And in this instance, we'll also look at other containers that are launched and see if we can put those together. Also taking into account headroom. So this one in particular is looking at making sure that there is enough space for containers that are going to be scheduled to be landed onto an infrastructure node immediately without having to wait for that process to be spun up. That's a real quick high-level take into what Spotinst can do for automating and more intelligently managing your infrastructure for your workloads. Primarily we looked at the containerized workloads and how it can significantly reduce not only the footprint, but also your cloud costs, taking significant advantage of those Spotinst discounts. At that point, finishing up on that demo, open it up for some questions from the audience if we have any in the feedback.
Cool, great. Thank you so much, guys. And I can attest that both of you have very meditative webcast voices. I really, really enjoyed listening to both of you. So that's just my opinion.
Thank you.
Okay, so we have a few questions for both presenters. Okay, Joey, this one's for you. Does Spotinst provide better visibility over AWS native Kubernetes services?
It does, as I somewhat showed there in the demonstration there. We do have deep insight into not only what infrastructure is matching to which individual pod determination and deployment, we also show the individual costings and metrics around each of those deployments. So you can really get a handle on not only how the deployments of those pods are scaling into the environment, how their utilization, but also how they're being matched to the infrastructure and which of those are actually associated costs directly to that pod. So that really gives you a lot of that chargeback, showback feature, really do real finite reporting back to the workloads that are running in different departments that you might have in different projects that you're running.
Great. Okay, Sebastian, so you talked a bit about some of the other options for storage services such as S3. So someone is asking, how much can they really save with archiving into S3?
That's the big question, isn't it? Well, okay, so let's put some numbers to that. So regular snapshots cost about 5 cents per gigabyte per month. Now, when I store that data, if I archive that snapshot into S3, then suddenly we're at about $0.023 per gigabyte. So it's about 2 cents. And then if you go one step higher and you're saying, well, I'm going to store it into infrequent access, then it's only about 1 cent per gigabyte per month. The only drawback with infrequent access is there is a 30-day commitment, which means I need to be sure that I'm probably going to archive this for longer than 30 days, because that's what's going to show up on your AWS bill. And then when I showed that little demo, and this was the sneak peek that we had with 2.7, you now also have the option to use intelligent tiering. Intelligent tiering in S3 is actually really smart. What it does is it almost has like artificial intelligence. It looks at how often are you using this data. In a very fluid manner, it moves the data between regular S3 and infrequent access. And it's almost like cheating, because when you're accessing infrequent access data, there is a retrieval fee of 1 cent per gigabyte. And that does not apply when you're using intelligent tiering. So that was a lot of numbers, and it almost sounded like we're doing a math test. Usually what you can say is, depending on which tiering you choose, we can literally cut that number of storage. What you're seeing right now in your AWS bill, we can cut that number in half. So even if you go with regular S3, the savings are about 60%. And if you go even higher into infrequent access or into intelligent tiering, you can ratchet that up to about 75%.
Nice. Okay. That's good news, definitely. Joey, someone has a question about Ocean Cluster support, supporting multiple AMIs.
Yes, that's a great question. So I briefly touched on the concept of launch specifications. And with that, in traditional sense, if you're trying to manage a varied cluster inside of a public cloud, for example, in AWS, you would have to manage multiple auto-scaling groups individually, all managed underneath that Kubernetes cluster. Each of those would have specifications to specific AMIs, subnets, etc., for that particular set of pods that would be running on that ASG. Inside Ocean, we have intelligence and the ability to create individual and multiples of launch specifications that can handle individual AMIs, different node selector labels, taints, tolerations, etc., all within the same cluster. So you're no longer having to individually manage a multitude of ASGs and monitor those and how they're actually scaling. We set one set of rules for the entire cluster. We're working on expanding even more finite, granular controls over each individual launch spec in terms of scaling and headroom. So those will be available soon. But right now, do all that definition in one place, get automated deployment and management of all of them together rather than having to separate those out into individual ASGs. So yes, we can handle multiple AMIs and other aspects even too within a single cluster.
Great. Okay, so I think we have time for one more. This one, Sebastian, we can touch on because I know a lot of organizations use identity providers. So someone is asking to log into your console, do you support SAML, SAML?
Oh, yeah, absolutely. That's a good question as well. So we don't have to use local users. If you have a single sign-on solution that supports SAML, ping, one login, or if you use Active Directory Federation services, absolutely, you can use that as well. It's going to work just absolutely seamlessly.
Awesome. Okay, so we're going to have to wrap up. Just a few points I wanted to touch on. So we covered two really great tools for AWS automation, and we really, really hope you enjoyed the presentation. Both N2WS and Spotinst have very easy to spin up free editions, which are fully featured. So all the aspects of the products that Sebastian and Joey talked about, and much more, can be accessed. So please, you'll get a link to that after the webinar in an email, and you can also click on the attachment and links tab over there. Please don't hesitate to reach out to us. You can either email me directly for N2WS questions or Joey on the Spot Inside. And also, we love feedback. You can there's a feedback tab where you can tell us, what topics you'd like to talk about, what other webinars you'd like to hear about. Specifically, we can deep dive into utilizing reserve instances, for example, serverless, building a CI/CD pipeline. Really, we'd love to hear your thoughts on that. And finally, we have very, very cool booths and prizes at reInvent if you'll be there. And we'd love to say hello. So please come by. Both companies have a booth there. And also, if you don't have a ticket, N2WS is running a promotion. We're giving away full conference passes plus an Amex gift card worth $1,000. So it just takes a quick form fill. Be sure to click on that link that you see over here. But last year we had a few winners, and they're still talking to us and thanking us because it was such an awesome trip, because it is. It's always fun in Vegas, so be sure to try your, because it is, it's always fun in Vegas, so be sure to try your hand at that. And that's it. So we're really, really happy to have you join us. Sebastian and Joey, do you want to sign off?
Oh, absolutely. Thank you very much for joining us. It was a lot of fun.
Bye, everyone.